Hello everybody, it is time for us to go over the topic 5 review. Oh, there's the bell. And like I have been lately, I don't actually have a answer key right near me for this one, so you're going to watch me do the whole thing, mistakes and all. It's going to take a while probably, but we'll get through it. So number 2, the blank is the point of concurrency of the angle bisectors of the triangle. That is the in-center. 3 or more lines that intersect at one point are called concurrent rather than intersecting. The points of concurrency of the altitudes of the triangle is the orthocenter. A perpendicular segment from a vertex of the line containing the side opposite the vertex is the or an altitude of the triangle. A point that is the same distance from 2 points is equidistant from the points. A blank of a triangle has endpoints at a vertex and at the midpoint of the side opposite the vertex, that is the median. All right, so those are your fill in the blanks. Number 8, if PS equals 36, PQ equals 3x plus 5, QR equals 6x minus 10, and RS equals 36, that means that PQ and QR will be the same value. So 3x plus 5 equals 6x minus 10. And then we'll go ahead and solve. Sorry for the tiny writing. 5 equals x. 15 divided by 3 is 5. But we don't want to know x, we want to know PR. So we can take one of those, PQ or QR, like 3x plus 5. Say that is 3 times 5 plus 5. That is 20, right? 15 plus 5 is 20. And then we have to double that. And when we double that, we get 40. So PR should be 40. Number 9, if PS equals 4x plus 8, PQ equals 29, RS equals 5x minus 3, and QR equals 29. Same idea here. We're going to set these two things equal to one another. So 4x plus 8 equals 5x minus 3. And solve. We find out that 11 equals x. We want to know we want to know PS. So PS is 4x plus 8. So 4 times 11 plus 8 is 44 plus 8, which is 52. So number 9 should be 52. Number 10, if JM equals 12 and LM equals 12, and the measure of angle JMK is 25 degrees, then that means the measure of KML is also 25 degrees because JMK and KML will be congruent angles. Number 11, if the measure of angle JML is 49 degrees and the measure of angle JMK is 24.5, which is half of that, and JK equals 17, then that means KL will be the same value since there's an angle bisector there. So KL will be 17. Number 12, a point on a perpendicular bisector is 7 centimeters from each endpoint of the bisected segment. So let's draw a segment, and let's draw its perpendicular bisector, like this. And it says a point on this perpendicular bisector is 7 centimeters from each endpoint. So 7 centimeters here, 7 centimeters here. Let me put my perpendicular bisector lines in. There we go. And 5 centimeters from the point of intersection. So let's see. Point on the perpendicular bisector is 5 centimeters from the point of intersection. So there's the 5, because that point is 5 centimeters from where that segment intersects. How long is the segment? So let's use a right triangle in the Pythagorean theorem and say 5 squared plus x squared equals 7 squared, since 7 is our hypotenuse. X represents half the length of the segment. So that's 25 plus x squared equals 49. Subtract 25 from each side, and I get x squared equals 24. And then I'm going to take the square root of that, and that's going to give me approximately, let's see, square root of 24, approximately 4.9. And then I know that my segment is twice that. So 2x, double that, is going to be 9.8. So it should be roughly 9.8 centimeters across the length of the segment. All right. Next, identify each point of concurrency, which one's the incenter and the circumcenter. It's pretty easy in this diagram because the only one of them that can be outside the triangle is the circumcenter. So 14 must be A, and 13 must be K, and of course we can tell because the point K is made of angle bisectors and point A is made of perpendicular bisectors, that we are correct. Down here, use the diagram to find each unknown quantity. So the measure of angle GFL is 34. Let me go ahead and write these in. So there's 34, and I see some angle bisectors. And the measure of angle GEL is 36. What is the measure of angle FGL? Let's think about this. So I've got some pieces of information here, and I know in a triangle it adds up to 180 degrees, and I know that there's some angle bisectors. So this angle is also 36. This angle is also 34. So if I take 180 and subtract all those angles, so let's see, 180 minus 2 times 36 minus 2 times 34, I'm going to get angle G. Let's do that. 180 minus 2 times 36 minus 2 times 34. That's going to give me 40. And then, since this is the point of concurrency of the angle bisectors, I know that G is also an angle which is bisected. So I'm going to take that extra 40 degrees, divide it by 2, and find out that my missing angle, angle FGL, which is approximately right here, is going to be 20 degrees. Let me go ahead and clear off all this stuff, and let's take a look at the next one. If JL equals 5, what is the measure of KL? Well, if JL and KL are both the distance from the incenter to the side of the triangle, they must have the same length because they are going to both be the measures of the radius of the inscribed circle. So that should also be 5. Number 17, the circumcenter of a triangle is on one side of the triangle. Explain how to find the area of the circumscribed circle of the triangle given the length of the sides. Ooh, interesting. So if the circumcenter of a triangle is on one side of the triangle, that must be the intersection of the perpendicular bisectors. So let's see if this makes some sense here. So if we've got a right triangle and we intersect the perpendicular bisectors of this side, so we would draw a perpendicular bisector, kind of eyeball that out, draw a perpendicular bisector of this side. It should be right on the right angle there. It says, explain how to find the area of the circumscribed circle of the triangle given the lengths of the sides. So if I know the length of this side right here, and I know the length of this side right here, then I would need to find the, the radius of a circle, and the circle would be the circle that goes all the way around all of these points like that. Hey, look, perfect. So that would be the circumscribed circle. So to find the area of that circumscribed circle, I would need to go from, let me give you another red here. I need to go from this point, which is the center of the circle, and I would need to find the radius, which in this case would just be half the hypotenuse, since from the center to the edge of that circle is half the hypotenuse. So what I would do is I would find half the hypotenuse, that would be the radius, and since the area of a circle is pi r squared, then that would mean that our area is pi times half the hypotenuse squared, just like that. It's a little bit of an in-depth question. We don't necessarily need all of that to understand what we need to know for the test. Down here, identify median and altitude. Well, FW goes from a vertex to the midpoint of the opposite side, so that's the median. And then EX goes from the vertex to the opposite side, so that's the altitude. Hits that opposite side at a right angle. Ooh, we got some orthocenter problems, and I have given them to myself without giving myself an answer key, so this should be fun. So there's A, B, and C. I'll find the slope of AB and the slope of AC. Why not? So AB is going to be 12 minus 0 over 2 minus 2. It's going to be 12 over 0. Hey, that's an undefined slope. It's a vertical line. For AC, that'll be 6 minus 0 over 8 minus 2. That's going to be 6 over 6, or 1. So then we find the equations of some altitudes. So I'm going to say altitude to AB. It's going to hit AB. Ooh, there's some thunder outside. And altitude to AC. It's going to hit AC. So the opposite reciprocal of an undefined slope is a slope of 0. So the slope of the line is 0. And then the point that the altitude to AB goes through is point C, which is at 8, 6. The altitude to AC will have a slope that's the opposite reciprocal of 1, which is -1. And it'll go through point B, which is 2, 12. It's going to be really easy to write the equation for the altitude to AB because the slope is 0. So it's just going to be y equals 6. There's no making that any more difficult than it is. It's just y equals 6. And then the altitude to AC, you might hear the rain. It's raining really hard right now. For the altitude to AC, we can put this into point slope form. Y minus 12 equals -1, parentheses x minus 2. And go in here, y minus 12 equals -x plus 2. And we will continue on. Whoa. Add 12 to both sides. And we get y equals -x, not -12, -x plus 14. So then we can go ahead and set these two lines equal to each other and say 6 equals -x plus 14. And then solve there. We already know the y coordinate. I should probably circle that one. That is one of the coordinates of our orthocenter. And then the other one here, we're going to subtract 14 from each side. -8 equals -x, which means 8 equals x, which means that the coordinates of our orthocenter are 8, 6. Perfect. Oops. There is some heavy rain going on. All right, next. The orthocenter of ABC is point B. What is the measure of angle ABC? So let's make sure that we draw this triangle correctly. It is going to be, well, I don't know if it's going to be a right triangle. Let's see. The orthocenter is on point B. So if it's A, B, C, then indeed the orthocenter, the lines that are perpendicular to each of the sides, are going to meet each other at point B, which is the right angle of our triangle. So that is 90 degrees. Find the orthocenter of this triangle with this given set of vertices. We've got A, B, and C. So again, we're going to find the AB and the AC. It doesn't really matter. That's just the ones that I like to find. So the slope of AB is going to be 6 minus 8 over 9 minus 7. That's going to be -1. And the slope of AC will be 4 minus 8 over 5 minus 7. That's going to be -4 over -2, which is a slope of 2. So then, got to find the altitude, 2AB, and the altitude, 2AC. So the altitude to AB has a slope that is the opposite reciprocal of -1, so that's +1. Whoops. +1. And the point it goes through is point C, which is 5, 4. The altitude to AC will have a slope of the opposite reciprocal of AC, so -1/2, and a point that is B, which is 9, 6. So then we're going to go ahead and make our equation. So y minus 4 equals 1, x minus 5. Solve that. Y minus 4 equals x minus 5. Add 4 to both sides. Y equals x. -5 plus 4 is -1. And then the other one, I've got y minus 6 equals -1/2, x minus 9. So that's y minus 6 equals, I'm going to do decimals, -0.5x plus 4.5, because half of 9 is 4.5. Going to add 6 to each side, and that's going to give me y equals -0.5x plus 10.5. So then I'll put these together. Say x minus 1 equals -0.5x plus 10.5. Solve this equation. Add 1. 1.5x equals 11.5. Divide by 1.5. X equals, let's see, 7.6, repeating. We're going to hope that this is right. And then we can plug in for y. So y equals x minus 1. Y equals 7.6 repeating minus 1. So y equals 6.6 repeating. So my answer would be 7.6 repeating, comma, 6.6 repeating. And there you go. All right. Next, a plastic triangle is suspended parallel to the ground by a string attached at the centroid. Show where the string should be attached. We don't need to copy the triangle. We can just say it's going to be exactly at the intersection of the medians. And of course, the medians are where the midpoints meet the vertex of the opposite side. So let me go ahead and draw some medians here. Just like that. And what we get is the centroid right there. Next, we've got lessons 5.4 and 5.5, these triangle inequalities. Determine if the lengths can form a triangle. We do that by seeing if the smaller two legs add up to be more than the bigger one. 14 plus 18 is not more than 32 because it's 32, so no. 14 plus 25 is more than 29, so that can form a triangle. 37 plus 22 is more than 56, so that can form a triangle. 35 plus 41 is not more than 87, so that cannot form a triangle. Down here, which angle has the least measure? It's going to be the one across from the smallest side, so that is angle Q, which is across from the 9.2 meter side. which angle has the greatest measure? It's going to be opposite of the longest side. So that's going to be angle R, which is opposite of the 12.3 meter side. Why must the sum of two sides of a triangle be greater than the third side? This is going to take some writing. You can explain it in a lot of any other words that you would like. Maybe what I would say is if the sum is not greater, then the sides, when we think of our popsicle sticks, would sort of collapse down and not meet at all three vertices. So if the smaller sides were not more than the long side, then the long side, they could not all meet end to end. They could not all meet end to end. But of course, you might have something different there, and that's fine. Number 31, two sides of a triangular garden are 6.4 and 8.2 meters. The gardener buys fencing for $29.25 per meter. What is the range of total cost of the fencing? So we've got to find the range of the amount of fencing in the garden. It could be that our smallest side, or that our missing side is our smallest. So x plus 6.4 would have to be greater than 8.2. So subtract 6.4 from each side. Let's see, 8.2 minus 6.4. It's going to be 1.8. So x would have to be greater than 1.8. And if x is the longest side, that means 6.4 plus 8.2 has to be greater than our long side. So I do 6.4 plus 8.2, that's 14.6, is greater than x. So x needs to be between 1.8 and 14.6. However, we also need to multiply that by 29.25 because that's the cost per meter. So if I multiply both sides by 29.25, 8 times 29.25 is 52.65, dyslexic, is less than x is less than, and then 14.6 times 29.25 is 427.05. So that will be the range of the total cost. Ooh, it's not the range of the total cost. That is the range of the missing side. So then we also need the sides that we already know, right? We need the 6.4 plus 8.2, which is 14.6. So 6.4 plus 8.2 equals 14.6. We'll multiply that also by 29.25. Let's see. That's going to be 427.05. So we're going to have to add that on to the missing side, which would have to be between 52.65 and 427.05. So we're going to say plus 427.05. Let's draw a little line here to separate that. Plus 427.05. So we should get, let's see, a total cost of 479.7 less than x is less than $8.54.10. So it's a little bit of a process to that problem there. Up here, write an inequality for the possible values of x. Well, x is going to be a side length, so it's more than 0. And it's going to be less than 23 because 61 degrees is a smaller opening than 64 degrees. So 0 is less than our x value, 3x minus 1, which is less than 23. So that's going to be adding 1 to both sides. dividing by 3. I end up with 1/3 is less than x is less than 8. And that's my possible values of x. Here, write an inequality for the possible values of x. I have 3x plus 6 degrees, which opens onto a 15.3 degree side, and 4x minus 7 degrees, which opens onto a 17.1 degree side. So I can say 3x plus 6 is less than 4x minus 7, and I can solve. So I can say, all right, that's going to mean that 6 is less than x minus 7. 13 is less than x. So x has to be greater than 13, which would also make it bigger than 0, which was our other concern, because if it's smaller, it might not be a number that we can use in these variables to get a triangle. But in this case, 13 should work. So let's see. Where's my colors here? Okay. Number 34, Cameron incorrectly says the converse of the hinge theorem proves that the measure of angle S is less than the measure of angle W. And if we knew the side lengths TS and RS and UW and VW, and if we knew that those side lengths were congruent in both triangles, then we could use this. But we don't know that those side lengths are congruent in both triangles. That's not information that's been given to us. So we cannot be, the hinge theorem cannot be used. The hinge theorem cannot be used because the adjacent sides of the triangles are not congruent. And there you go. That is everything on this review. Let me know if you've got any questions whatsoever, and have a wonderful day.